In today's lab, you're going to need the optics bench, the ray table degree scale, the ramp, these 4 stands, this half moon cylindrical lens, and the slit mask and slit plates. For the light source, you can either use this box right here if it has a light inside of it. This one has a light inside of it. Or if you don't have one of these, or there's no light, or there's no bulb inside, you can use your phone and use the LED of your phone. So here we go with this. If you have a light setup that works, and as you can see, this light bulb works. This is the equipment I'm going to need. Okay. So I'm going to start with the ramp. I want to make sure that the ramp, the lowest side of the ramp, is facing the light source. So I want the lowest side facing the light source, and I can bring that kind of close because I want the light to make nice rays for me when I set this up. Then I'm going to put this on top. Now make sure that you put this side up, not this side. I want this side up, okay? Then I line up this hole with this little notch right here. Okay? So, okay? And then make sure it twists nice and easy. Okay? And then I also want to make sure that the normal is pointing, one of these normal arrows, either this one or this one, is pointing towards the light source. Okay? The next thing I want to do is I want to take this, make sure it's flat on the bottom, okay? You don't want to use this one, okay? You see how it's got the notches at the bottom. You want to use the flat one, which is this one right here. So I put the flat one down like so, and then I'm going to use my slit plate, okay? So I take my slit plate, put it over here, and then I'm going to use the slit mask to block off all but one of the beams of light. And then this will get placed on here with the flat edge of this matching the component line on this this ray table degree scale. Okay, so now you can see that there's a beam of light, one beam of light, and only one beam of light going through this normal line. The next thing I want to do is I want to take the cylindrical lens, okay, that looks like a half moon, and I want to line up the edge of that with the component line and playing around with, but ideally, and it's not quite lined up yet, and I can tell that because this beam is not lined up with the normal. If I take this off, you can see it is, and so when it's set up properly, like this, the beam of light goes straight through the normal line. But I want to make sure that this is also lined up. This is also lined up on the component line. And let me get it set up. Now this is all set up properly. You can see that the beam of light starts at 0 right here and comes out to 0 right here while going through this this glass tube. Okay, so now here's the data table. After we got their setup, our data table is going to guide us on what to do next. So we have our incident ray, and this is with the flat side facing the source. So we're going to do 0 degrees, 10, 20, 30, all the way to 90. Now we might not be able to get all of them, but we're going to get as many as we can. And then this is the refracted, which is what we're going to record. So coming in on this side, this is the incidence, which is these values right here. And I can change the incidence by rotating this table. And as you can see here, there's 10 degrees, 20 degrees, 30 degrees, so on and so forth, okay? So if I say go to 10 degrees, I'm going to come over here and I'm going to look at the result, and the result is going to be about 6.5 degrees. So I'd come over here, and for the refraction, I would put 6.5 degrees. Then I would move on to the next one, which would be 20, So this is your incidence, and this is your refracted for 20, then 30, and then all the way over to 90, okay? And then notice that you get to about right here, and it just doesn't quite go through. So this is about the limitation of what you can get on this side. Part 2 of the lab is whenever you're going to put the curved side facing the light source, okay? So now here's the flat side facing the light source, and so all I'm going to do is I'm going to very carefully twist this, because remember, there's no magnet holding it in place like before. And what I want to do is I want to put this on the 0 right here, and I also want to make sure that it comes out to the 0 on here. Now notice it does not. So what I want to do is I want to tweak this until, make sure that the flat side still stays on the component line, and I want to make sure that that beam of light goes straight through the normal line. Now I have lined it up. And what I did was, you can see here, it starts out at the 0 and comes out at the 0, and it's about as precise as I possibly can make it. Okay? Then I come over here, and these are my incidence rays, and I'm going to write down the refraction over here. So what I'm going to do is, I'm going to, again, the same thing over here, I'm going to put this at 10 degrees. That's my incidence. So this is, you can see here, this is 10 degrees right here, and over here I have 10 degrees. And then here's my refracted ray, and that comes out to be about 14. So I would come back over here where it says 10 degrees, and right here I would put 14 degrees. And then I could just continue that all the way through and getting all the values I possibly can. So that's the setup for today's lab. Just make sure that you are always constantly checking to make sure that this flat side is on the component line. And always, it's no shame in going back to double checking to make sure that the beam of light is lined up at the 0, okay? Because if it's not, you're not going to get very good results.